So let's go to the chapter, to our notes. Okay, what do we have in chapter 11? So this is about two sample tests, means that previously we have one sample test. One sample test means you have one population, and from that one population you draw a sample. So you call it one sample test. So the question for one sample test means that they will ask whether the means of something, like means of the chairs, means of the CGPA, or means of whatever, equals or not equals, smaller or bigger with certain number. Okay, so that is how the one sample test question look like. You are only talking about one thing, but in this case you are talking about two things or two samples. So we have two population, and each population you draw a sample, so you're going to get two different samples. So the samples, although they are different, but they are not that much different. Okay, as I mentioned in the video, perhaps you are comparing, like for example, you have two samples here, right? So you are comparing a green apple with red apple, okay, versus. So you are comparing apple as well. In total, these two are apple, but the first one is green. The taste is maybe different. The second is red. So you are comparing two different apple, okay? So you cannot compare apple with durian or apple with something else. So you should compare something similar, okay? So this is all about two sample tests. Okay, so what do we have under two sample tests? Not that much. You only have independent sample and dependent. So under dependent, you only have what we call it T formula. You don't have Z because under dependent we are only talking about a sample. We will never talk about a population. So that's why you only have T. Okay. Under independent, you can have Z and you can also have T. What is the difference between Z and T? Anyone?
Sigma.
Sigma. So your sigma will be given in Z. In other words, your population standard deviation will be given if you want to use Z distribution. So make sure that you are not confused between sigma and S, because sigma is population standard deviation. Sometimes the standard deviation is given, but the standard deviation might be referring to your sample standard deviation. If sample, it doesn't count as a sigma. Okay? Okay. So now, let me see. I don't remember what is your question. What is this? Okay, let's read this together and let's try to answer it together as well. Okay. Okay. I think this is fine. Or maybe make it so that we can see side by side. Okay, a number of theft incidents occur at IIUM Mahala in Gombak campus. Let's assume, okay? Let's assume. This is just an example. Don't think that this is the real situation. Okay. The Mahala principal claims that, I should put S, claims that CCTV should be installed in all levels. Well, as in like we are very rich. In all levels, can reduce these incidents. Okay, because you know that when we install a CCTV, well, people may be cautious about their action. The IUM rector has agreed to a proposed experiment, right? The 8 Mahala were chosen randomly. So 8 Mahala were chosen randomly. What does it mean?
Sample is A.
Yes, we are talking about the sample. And the CCTV were installed. So we are not talking about the Z, okay? We are talking about the T. Now you have to focus on the T because we are talking only on the sample. The number of theft incidents during a one semester periods are as follows. Okay, blah, blah, blah. Okay, at the 0.01 significance level. So what is this 0.01? This is your alpha. Is it reasonable to conclude that the installments of the CCTV reduced the number of theft incidents? Okay, now, so all, so you have to refer to your table, okay? So what should we do? What is the first step should we do? So this is hypothesis. You're gonna have, well, 6 steps. So first steps, what is it? H0, H1, and then next, what is your H1? Is it reasonable to conclude that? So normally when you want to somehow formulate your H1 refers to your hypothesis. You have to refer to the question. Sometimes normally, well, by default, the question will be given at the last sentence. But sometimes it can also give you in the somehow in the beginnings or in the middle. So you have to find out where is the key words, where is the question. Is it reasonable to conclude that the installments of CCTVs reduce the number of theft incidents? So what should we do? The mu of what? Mu of, so now, okay, before that, are we talking about independence or dependent?
Dependent.
Dependent.
Okay, it is clear, right? Because you have like before and after CCTV. Well, the words before and after shows that these two samples are actually the same sample. Okay, okay, so let me just give the introduction. Dependent and independent sample. So dependent normally refers to one item, like one object, but then you evaluate it at different times. Means that there is like some intervention here, and then it has two values. So this is like before CCTV or whatever it is, like this is like this is the before event, and then this is after event. So what is the intervention? Intervention is CCTV, but the mean or the observations are the same thing. So this is like the same thing, and then because of the CCTV, then you're gonna have a different somehow like different condition. While for independent, you are talking about two different things. For example, you are comparing what? Yeah, this is the green apple, right? So comparing two different things. We will look at the example soon. Okay. So now you know that because you have the before and after, so you are talking about the same sample, but you have the interventions of CCTV, so you are calling it, you consider it as dependent. Okay, now, so is it reasonable to conclude that the installments of CCTV reduce the mean? Okay, the number of theft. So the mean of what we call it after installments of CCTV reduce compared to the means of before CCTV. Means that the means of theft incidents after you have installed the CCTV definitely can reduce the number of theft incidents comparing with the before installing the CCTV. Okay. So there are many ways on how to put the what we call the hypothesis. So let me tell you, this is like the first what we call the first example. Okay, so is it clear? So the means of after installing the CCTV should have a smaller incidence of theft compared to the mean before CCTV. Is it clear now? Okay, because I'm going to show you like different examples of how to formulate the H1. So since this is less, so it should be easy. Mean after should be bigger or equal than the mean before. Okay, you can have these types of hypothesis. This is the first example. Okay, the second example, you can write it like this. The mean. Oh, give me like 1 second. My battery is running out. Is it? Okay. Okay. Now it's good. So, where's the question? It's here. Okay, this is the second example. So you can write mean. Where is it? The mu after minus before. You can write it this way. Should you assume that after the installments of the CCTV, definitely the mean will be smaller. Okay. Okay, smaller than 0 means that you are assuming that the difference between these two, because you are writing here mean after minus before should be smaller than 0, means that the after should be lesser than before. You can write it this way, and then your h null could be mu mean difference bigger or equal than 0. Okay, so you have, if you want to use the difference word, which is d, you have to define it. Doesn't matter you want to define it at h null or at h1. You should define the difference. Okay, so difference means which one minus which one, because when we talk about difference, are you referring to after minus before or before minus after? That's why if you want to use the word difference, small d, you have to define it. Which one minus which one? Because you can also have something like this, like if let's say you want to put here the mu before minus after. So before minus after, the signs will be different. We will assume that before, the number of theft cases should be bigger compared to after, right? So you can have mu difference, and then the sign will be smaller or equals than 0. Okay, so if you want to put the word difference, you have to define it. What do you mean by difference? After minus before or before minus after? If you want to define it as after minus before, your sign will be smaller, because after installment of CCTV, definitely the number of thief cases will be reduced. But if let's say your difference is before minus after, then the sign will be bigger. Before the installments of CCTV, people can do whatever, right? So the number of thief cases may perhaps larger. Okay, got it? So in what we call it dependent, in the dependent test, the dependent sample test, you can use the D sign, which refers to difference, but you have to define them. If you think that it's hard to use the D, then you can use just the simple one. Mu after is smaller thief cases compared to mu before, and you can just make it you make your life easier. But if you want to be like, I don't know, if you think that putting different can show that your understanding level is better, then do it. But make sure that the difference is specified. Okay, make sure that you are not confused by yourself. Okay, that is the what we call the explanation. Second, this is a hypothesis. You have a steps, which is your alpha, 0.01. So let me tell you, give you a reminder. Make sure that you look at the alpha value carefully, because sometimes people may get confused. 0.01 and 0.1 are actually two different things. So look at it. Is it 0.01 or 0.1? Because they have different value. Okay? Number 3. What is number 3? What should we put it here? Anyone?
Use T.
Yes. Number 3 is test statistic. So because we are talking about dependent sample, dependent will always use T. Then you have to use the formula. What is the formula of T? T is difference D bar. Is it looking like D or looking like 9? Okay, so D bar over standard deviations of the difference divided with square root of n. This is your D. To find the D bar, well, basically to find the T, you have to compute the D bar and you have to compute the ST, standard deviations of the difference. So these two calculations need some time. You cannot finish it in 10 minutes. Well, that's fine. That's why I give you extra time. But for those who can finish it on like within that 10 minutes, well, it's amazing. So, let's focus on the D bar. Okay, because I want to show all the what we call it the steps in this one sheet. So perhaps I will put the working for the D somewhere here. So how to compute the D bar? What is D actually? D is the difference, right? What is D bar? It's like X bar. What is X? X is your observation. What is X bar? X bar is, what is it? The mean of the observation, or we call it sample mean. So D is the difference. When you have the bar, the means of the difference. Okay. So how to find the D bar? The same formula with the mean, the X bar, the same formula with the X bar. So how to find the X bar? summations of all your x divided with n, right? So the same thing with the d, okay? So summations of all, what we call summations of all your d is like your observation, okay? So x bar, x is your observation. So now summations of all the d, the difference over the n, okay? So don't feel so hard about it because they are alike, okay? So how to compute the d bar? So you have to compute the d, the difference first. Okay, now here is the not really tricky parts, but okay, let me see. Where is our okay? So now, if let's say this is your H1, you are looking at after minus before. You are saying that the mu of after is lesser than before. So after is your first observation. You want to look at the after. So you have to take the value of after minus before. Okay. If let's say you take this one, before minus after, then you have to take the value of before minus after. In this case, after. So after is the first observation. So what is the after? After 3. 3 minus what? The observations of the before. 3 minus 5.
5.
And then what else? Plus summation, right? It's like the x bar. Plus the second observation, what is it? 7 minus 7. And then plus, what else? 7 minus 7, okay. 7 minus 6. Plus until, what is the last value? 2 minus 10. So this is the difference. You want to see the difference, right? So the after, this is the after minus the before. And then divided with the n. How many n's do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8. So given all this working, what is the value that you will get? Negative 2.5. Okay, because the value after CCTV, you are expecting the less number of theft cases. That's why you're going to have negative for after minus before. But if you take before minus after, the value will be positive. Okay, that doesn't matter. You will get like, even though the value will be different, but your conclusion will be the same. Okay, so this is d bar, negative 2.5. So please ignore this x bar. This is just the example. Okay. What else? After d bar, you have to compute the standard deviations of the difference. This is like our standard deviation, but we are talking about the difference. What is the formula? You're gonna have square of summations of d is like your observation, like your x minus d bar squared over n minus 1. So if you take out this d, if you erase this d, our normal standard deviation is just summations of x minus x bar squared over n minus 1. They are the same, but here your observation, instead of x, it is d. Okay, so how to compute it? So you have to look at the d, right? The difference. What is the difference for the first one? 3 minus 5. What will you get? Negative 2, right? So you will have negative because we are talking about the reduction after the installment of CCTV. So d minus, your d is negative 2 minus d bar. Your d bar is already negative 2.5. So minus negative 2.5. So it will be positive here, negative 2 plus 2.5, if you want to make your life easy in the calculator. And then, what is the second differences, second observation for d? 7 minus 7, you will get 0 minus negative 2.5, negative 2.5, plus blah, 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 until the last observation, which is 2 minus 10, negative what? 2 minus 10, negative 8, minus negative 2.5. Okay, I forgot. You have to put squared here, squared, squared, and then squared here. Okay, remember squared is there in the formula. And then divided with what? N minus 1. Your n is 8 minus 1. And then don't forget this square root. This. Okay. So given this working, you should get the value of, okay, if let's say you compute it one by one instead of computing all of them, because sometimes our calculator has a limit. So you will get 60 here for the top one over 7 because 8 minus 1. And then if you want to put the square roots, you will get the value of what? 2.928. This is the value. Okay. Yeah. Yeah. That's right. That's right. Why you don't have the negative sign? Because previously our d bar is negative, and then the difference is also negative. Why do you have positive? Because you have this squared. When you put squared, all the negative value will be positive. Okay. So far so good.
Good, madam.
Okay. And then after computing the d bar and then SD, and then you will have to compute your t. What is the formula for t? I forgot. What is it? Anyone? D bar over SD. Okay. So the t is d bar over standard deviations of the difference square roots of n. Okay. Now, what is the d bar? Just plug in everything, right? So d bar is negative 2.5 over standard deviations of the difference, which is this one, 2.928 over square root of n. N is 8. So given all this working, you should get the value of, because this is negative 2.415. This is your t value. So negative 2.415. Remember that. Where are we? So negative 2.415. Okay. So it's a long working to compute the t somehow. Okay. And then this is number 3. Number 4, your CV. So how to compute the CV? Can anyone tell me? You have to refer to T table. Okay. So how to do it? Tell me how to look at it.
One tail test.
Huh?
Alpha 0.01.
Okay.
EF 7.
Uh, Alpha 0.01. Okay. So there are two alpha, 0.01 here, 0.01 here, and then is it one tail or two tail?
One tail.
It is one tail because this is less. I mean, if you have more, it is also one tail. Unless you have equals or not equal, then you have to look at two tail. So this is one tail. Okay, so what should I do? We know that it is one tail 0.01. So it is one tail 0.01. So how to look at it? What is your degree of freedom?
7.
7. What is the formula of degree of freedoms for dependent sample?
N minus 1.
N minus 1.
Okay, cool. So I just wanted to tell you, okay, for what we call it independent sample, the degree of freedoms is n1 plus n2 minus 2. Why? Because the two groups are different. That's why you have to plus them first and minus 2. But for the dependent, they are the same things, isn't it? But you, so where is it? See? And just n minus 1 because the observation are the same. Where is it? Where is our question? Okay. So n minus 1, what did you get?
8 minus 1. 7.
Degree of freedoms n minus 1. So even though you're going to have like 16 observation, but basically before and after they are talking about the same object, but then you're going to have intervention. So that's why you have different value. So 8 minus 1, you're going to have 7. So, okay, where is our t table? So 7, okay, 7, and then you're going to have 1 tail and 0.01, right? 0.017, 2.998. Is it true? Is it correct?
True.
Let me double confirm with the answer from the textbook. Well, I had it very much because sometimes they give like the wrong answer. Yeah, that's correct. Okay, that's correct. Okay, so just to be confirmed, your CV could have a negative or positive value. So all the answer given from the T table will be positive, but you have to double confirm whether it is negative or positive. How to do that? So you have to check your H1. Okay? So this is less. What does it mean? Your CV will contain negative sign. Okay? So then you will draw your diagram. So where is it? Let's put it here. Negative 2.998. And then where is our T? This one. So where is it? Inside or outside the rejection region? Anyone? Inside or outside?
Outside.
Outside.
It's good. It's good. It is outside. This one. Negative. Okay, let me just put the T. Okay, it should be outside the rejection region because in the middle is 0. Okay, so now it's outside. So number 5, what is your decision? What is your decision? When it is outside, you can say, do not reject the H null. If it is inside the rejection region, then you have to say reject. But it is outside, do not reject the H null. What is your H null? This one, the first line. So number 6, interpret. So if you do not reject the H null, what can you say? We fail to show that the mu of after is actually less than the mu of before. Okay, you fail to prove your own hypothesis, your H1. Don't put we fail to show H1, rewrite the H1. We fail to show or to prove that the means of after installations of the CCTV can reduce the number of theft compared to the before the installations of CCTV. Okay, is it clear?
Clear.
Okay, then let's see. Where is the question? This is I don't know. This is perhaps section 6. Let's see section 5. Oh, okay. Well, the same thing. They are the same thing. Okay. The IIUM Rector recently granted funds for a special program designed to reduce the theft issues in all mahalas. A study. When we talk about a study, we are referring to a sample. A study of the results of the programs in 8 mahalla in Gombak campus yielded the following result. Okay. Has there been a decrease in the number of thefts since the inaugurations of the programs? Since the implementations of the programs. So you have to use 0.01 significant level. Oh, well, the same thing, right? So you have before and after. We are talking about dependent. So you will have all the steps. Do you want me to show the working, or I can just skip this?
Madam,
Yeah.
for this question, it is same as before, right?
Yeah.
So I think back for the previous question, if we use uh, for the difference, we use before minus after.
After.
So all the answer is wrong, I think,
No, 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 no. Okay, no. Okay, let me see.
because of
Where is
the
it?
negative.
No, no. If you use before minus after, right? You are saying this. If you are using this before minus after, so your answer will be the same, but you will get positive. Okay. So what happened is that let me show. Okay. I wanna open this one. Okay. Let me show it side by side so that you can compare it. It's good that you ask so that everyone can see it. Okay. Now, if let's say this is your H now and H1, right? Okay, so instead of using after minus before, you want to do before minus after. That's fine. Mu before minus after, you should get bigger number of theft, right? Because before it should have bigger value. And then you can use mean difference if you want to. And then this is bigger, smaller than 0. So what happened is that when you use this smaller, all your number will be negative. But if you use before, because before will be large number of cases, all your number will be positive depending on your sign here. And okay, number 2, you will have the same 0.01. And number 3, if you use this formula to compute the t, you will get the value of positive 2.41415. Okay, for the number 4, CV, right? You will compute the same values. You will get 2.998. Remember, as I told you, the CV, when we refer to the T table, the value will be all positive. Your job is to confirm whether CV is positive or negative, right? Looking at the H1, the signs of the H1, because CV will follow the signs of H1. So now your H1 is positive. So your CV will be positive. And when you draw a diagram, okay, so you will see, we call it shaded in the right side because everything's positive. So your CV, this is the area, 2.998. So what happened to your T? T is 2.41. Is it inside or outside?
Outside.
Outside. So this is your T. So what is your decision? Number 5. Your decision is still the same. It is outside the rejection region. You will say, do not reject the H now. Then the same thing. You will have the same value, the same number, but the only difference is the sign, whether you are looking at the left side or right side. That's it. You will get the same answer. Okay, got it? Okay. Okay, it's good that you asked so that everyone can see what happened if I use the bigger one. What happened if I use the less one? So you're going to have the different area that you are looking at. Okay. That's the explanation. For this one, even though we are talking about the incidence of theft cases, but the number are different for 2 different quizzes. So do you want me to compute or you want me to just give the answer? So it's not fair if I didn't compute it right for this section. Okay, so what is the H1? Tell me. What is it? Is it reasonable to conclude that the installments of CC are the same thing? Is it? No. What is it? This is D. Let's see the C. This is the section 5. What is the question? Has there been a decrease before it's reduced? Decrease in the number of thefts since the inaugurations of the program. Okay, so it depends on you. You can say mu after the programs. You are assuming that there is a decrease, right? So mu after the program is decrease is smaller than the mu before the program. Okay, you can just use the simple one instead of using the difference. The mu after bigger or equals than the mu before. And then you have your alpha, whatever the value, 0.01, and then you're going to have your, what we call it, T statistic because you are using the dependent. So the T, I haven't computed it, but well, so what is it? This one. So the T, the value is, where is the T? T. Where is the T? I don't know. Wait, where is the T? This is step 4. They didn't even compute the T for you. Here, did they compute? Oh, they did. They didn't compute it. This is the CV. Okay, they just give the, okay, don't worry. So, what is the formula for T? D bar over SD, standard deviations of the difference, divided with square root of n. So the D bar here, 3.625, just for those who have answered this question. So I wanted to give you the answer. So 3.625. Well, the same working as we have computed before for the D bar. Okay. And then over standard deviations of the difference, here the value of 4.8385. And then divided with square root of n. How many n's do we have? I don't remember. 1, 2, 3, 4, 5, 6, 7, 8. 8. So 8. So given all this value, what is the value? What is the answer? I don't remember. I don't know. 3 point.
2.119.
Okay, let me double confirm. Okay, 625. So 4.83. Oh, this is like 4 decimal point. 8385 divided with square root of what? 8. 2.1. Yeah, exactly the same. Okay, so this is your T, and then number 4, your CV. So this is small. If I want to put it small, the textbook they use bigger, doesn't matter. Okay, small. So what is the value of CV? 2.998. And then because it is small, my H1, if you look at here, my H1, it is small. So my CV has a, because, yeah. So my CV has a negative. Since I started with after, which is a smaller value, so my T will be negative. My T will be negative. If I start with before, before compared or minus, let me put minus. Before minus the after, then I will have a bigger value. Then that's why everything will be positive. But now, let me stick to the smaller, after minus before. So my T will be negative, the CV will be negative, and well, I have to draw the diagram. 2 point, let's assume that it is here, negative 2.998. Where is this? 2.1. 2.1 should be outside. So this is the answer. Number 5, decision, because it is outside. Do not reject the H now. Okay, so if you look at here, the answer is do not reject the H now because they are looking at the bigger side. So the positive, all the value for what we call the T and CV are positive. That's fine. It depends on our hypothesis. And number 6, because we do not reject the H now, we are saying that interpretation, we failed to prove or to show that the mean of after the program is actually smaller than the mean before the program. That's it. Okay, that's it. So far so good.
Yes.
Okay. Let me show you one more. What is it? This one. Okay. Okay. We'll make it fast because it is not that hard. Okay. So all of you can just look at this question together. Okay. As a student of ECON1140, I am assuming that you should know what class is this. You would like to compare the weekly expenses of accounting students, we call it BACC, and BBA students. You collected the following sample. So, okay, so here you have two samples, BACC and BBA. So what can you say about this? Is it independent or dependent?
Independent.
Independent, because accounting students and BBA students are not the same students, right? In your question, you are talking about the same items, but then you have the intervention, which is CCTV or program. That's why you're going to have different value. here you are talking about different students. Accounting students are different students. Business students are different students. So you are talking about independent. So is it Z or T?
T.
Because you are talking about a sample, so this is T obviously. Okay, so well, let's just go through to the steps. H0, H1, blah blah. So what is your H1? Can you conclude that the mean weekly expenses are greater for accounting students than the business students? So the mu for BACC is greater than the mu for BBA. Okay, once you know how to formulate your H1, you should be able to go for H0, which is smaller or equals than this. Okay, you can just write it. Number 2, your alpha is, this is 0.10. Okay, it may look like 0.01, but it is 0.10. Number 3, so you know that you have to use T. So what is the formula for this? Do you remember? You don't remember, right? So the formula is x bar 1 minus x bar 2 over square root of, we have here what we call pool variance. S squared, S is standard deviation. When you have the squared, it's become variance. 1 over n 1 plus 1 over n 2. This is the T, but it's not as easy as it because you have to compute the pool variance. And you also have to compute the mean of these two what we call sample. Okay, so do you know how to compute the mean, the x bar? Summations of all, what is the formula for x bar? Summations of all x divided with the n. Okay, so if you want to compute for x1, so you have to compute in this case because I'm talking about accounting first, then the BBA. So my x1 is accounting student. So summations of the first one is like what is it? 136 plus 142 plus until 165, right? Divided with how many observations? 1, 2, 3, 4, 5, 6. Is it 6? 6. Okay, given all this, what do you get? You should get the value of, well, you can practice it at home. You should get the value of 142.5. And if you want to compute the x bar 2 for business students, the same formula, summations of all 120 plus what, 139 until 149 and divided with how many? 7. You should get the value of 130.28. So this is just x1 and x2. You are not computing the pool variance. Okay, so this is just like your formula in independent sample. So what is the formula of variance? Variance. Anyone remember how to compute the variance? Okay, let me put the formula of standard deviation. S equals to summations of x minus x bar. In your case, d minus d bar, right? So the same thing. And then you have squared here and n minus 1. So what is the observation? X, right? Because in this formula, what is the formula? Oh, okay. I should have a different separate sheet so that I will not disturb all this flow of the hypothesis. Okay, doesn't matter. So what is the observation? So what is the observation? Oh, before that, I have to tell you what is the formula for pool variance before we want to compute the variance. Okay, the formula for pool variance is, before I'm using this formula, where is it? Okay, let me delete this first, equal. Okay, so this is pool variance. The formula is n1 minus 1. And then you're going to have variance in sample 1 plus n2. This is the sample for the second part, minus 1. And then you're going to have the standard deviations for or variance in the sample 2. Okay, and then you're going to divide it with n1 plus n2 minus 2. So you have to compute this first. Okay, the pool variance. Okay, now that's why I put the standard deviation. It is actually here. But when you don't look at the pool variance formula, you don't know why do I put the standard deviation. That's fine. So N1, how many N do we have? For number one, 6, right? You have 6 observation. So 6 minus 1. And then you have to multiply with standard deviations of the BACC student. So this is the formula that you have to use. So you have to take the X. What is the X? 136, right? This is the X, 136. I hope that you can see my cursor. 136. And then you have to minus the X bar for the first observation, which is 142.5. And then don't forget the squared. And then do until whatever. And then you divide with the n minus 1. So 6 minus 1, you will get 5. And then you put the square root. It will become messy because I don't have that much space. But for the S1, okay, for the S1 here, you will get the value of okay, 2.243. This is someone please silence your who's that? Okay. I still can hear your voice. Who's that? This is I don't Nur Elina. Can you please mute yourself?
Sorry, madam. Sorry.
Yeah, okay. So this is S1, the value for standard deviations for sample 1. And using the same formula, you will get the standard deviation for sample 2, which is equals to, what is it? 15.787. And then just plug it into the pool variance formula. So the pool variance, you should get the value of, because I didn't put in a separate sheet, so it's becoming messy, right? I'm sorry for that. So the pool variance, you should get the value of 204.076. Okay. Then you can plug into the formula of T. So, well, perhaps I have to open a new one or else you will get confused. I should actually separate the formula for computing the T, but I forgot. So the T, you will have the X bar 1, which is, what is the X bar 1? You got 142.5 minus the X bar 2, which is 130.28 over, okay. So your pool variance, what did you get? 204.067. And then multiply with 1 over N1. So N1 is 6 plus 1 over N2. N2 is 7. Given all this working, you will get your T value equals to 1.535. Okay. Well, because all these messy stuff are disturbing my hypothesis steps. Okay. After computing the T, then you're going to have your CV, the same steps. Okay. So you have to look at the T table. Yeah. What is the T table? Do you want me to look at the T table, or we can just skip this? Because we have discussed about how to look at the CV, right? So let me just show you the answer for that. What is the T? No, this is not the T. The CV. The CV is it number 1? Yeah. 1.363. So 1.363. Why the CV is positive? Because you are taking the positive value. In this case, you are, BACC bigger than VBA, so positive. So, yep, then you will draw your diagram as usual. The CV is, well, It's not on the left side. It should be on the right side. It's positive, right? So 1.363 and this one is 1.53. So is it inside or outside?
Inside.
Yes, 1.5 should be inside. So this is your T. And the next step is make a decision. So because it is inside, so you should say reject hash null. And then number 6, because you reject the hash null, so you should say, well, because our hypothesis is somewhere here, right? Because you reject this, the hash null, you are saying that definitely the mu, you should say the mu of accounting is lesser than the mu of DBA. Means that the spendings of accounting students is smaller than the spendings of the DBA students, because accounting is so calculative. That's why, perhaps. Okay. So, yeah, that is the answer for section 1's question. And if you look at the section 2 question, well, the same thing. Let me just because they are the same thing. So let me just go through it. The number of the manufacturers of a calculator wanted to know whether a 5% discount in price is enough to increase the sales. You believe that when they give a discount, definitely the sales could be increased. But we want to test it, whether it is true or not true. To investigate, the manager randomly selected 8 shops. So when we talk about randomly selected, you are talking about a sample, right? 8 shops, and sold the calculator at a discounted price. So you have like 8 shops where the manufacturer will sell the calculator at a discounted price. And then at the 7 randomly selected shop, the calculator was sold at the normal price. So here, let me see, painting. Okay, so you have 2 things here. So you are talking about discounted price and normal price. Okay, so these 2 are talking about calculator. Okay, but the first one is discounted price. The second one is the normal price. So we wanted to know whether if we sell it at a discounted price, our sale will be higher or bigger than this one. Okay, right. Okay, below is the number of units sold last week at the normal and discounted prices at a random selected shop. Okay, so can the manager conclude that the discount resulted in an increase in sale? Okay, so how we want to somehow formulate the hypothesis? We can say, okay, now H1, we can say the means of the discounted price will increase the sale compared to the mean of the normal price. Once you know how to formulate your H1, well, your H0 will be just the opposite and equal sign, and the remaining will be the same. Okay? Anything else? I don't think I should solve the question because it is the same like the previous one. So do you have any question?
Madam, I have a question about project. The last date for project submission is 17th of February, right?
My class schedule. So revision period exam. Okay. The last date of. Oh, okay. No, the last date of your project submission is on the day of your exam. So when you look at the class schedule, this is exam period, starting from 3rd until 17th. So along this line, you're gonna have your date for exam, for statistic exam. So that date will determine your what we call your submission date. Okay.
Oh, okay.
Mm. So anything else? But if let's say your statistic exam is on the 3rd, and you think that you need sometimes, well, I can allow up to like 10. Okay, maybe yeah, up to 10. Maybe 10 is the maximum. If let's say you get earliest date, at least I can give you extra time. But you cannot submit at 17 because after you finish your exam, we are given like maybe 5 days to mark everything. So in 5 days, I want to check, I want to read all your project paper and everything with 4 section. I don't have, I couldn't do that. So I need to somehow have some times to check everything. And I also will somehow be after checking, after grading your marks, I will share it with you. And if let's say during that time you have some uh, corrections or anything, you can give it to me. If let's say you submit it on 17, and if there is an error, so I have so we have to submit to the kuliah, so I cannot do any changes. Okay, so yeah, that's why. So anything else other than that, I have to stop recording.
No, doctor.